Hello, revo.js. I'm happy to be here. I don't know if I'll have the same level of energy as Eric, but I hope you'll at least learn something fun in my talk. I want to start with a story. At my job, I have the same clicker problems as everyone else. So at my job, I've been working on the same project for a number of years. And it's an application to allow you to build dashboards to visualize all sorts of data that you might have. This is a production application that is relied on by many Netflix engineers pretty much every day, and so it needs to be rock solid in production. About a year ago, though, my team decided to start working on a new product. This was going to be a product to allow our engineers to more easily explore all of the data that they had powering their dashboards. We decided that this was going to be a big new experience, but we still wanted to build it in the same project. The reason being is that this would allow us to pretty much just adopt and inherit all the best practices and tooling that we already had, including things like our test infrastructure. So we were able to get up and running with this new project really quickly, and things were going pretty smoothly and our development velocity looked good until one of my teammates came up to me and one day expressed frustration over having to write tests and, more importantly, or annoyingly, rewrite tests as all of our requirements were rapidly changing in these early stages of development. He made a pretty convincing argument to us that what we were doing was actually causing more harm for our development than good. Those of us that had worked on the project for a while, though, were a bit resistant to this idea. We were like, this testing strategy had worked for the last project. Why won't it work for this one? And obviously, we didn't feel like we could ship features without writing tests for them. It just felt really bad to us. So what did we do? That's what this talk is going to be about today, testing your testing strategy, or perhaps more on brand for this conference, rethinking your testing strategy. That is, how do you create a testing strategy that makes sense for your particular project, your particular team, and the particular stage of development that you find yourself in? Because what you might have used in the past may not necessarily be the best approach for what you're working on now. So I'm going to unpack my team's story a little bit more, as well as just share a bunch of insights that I've kind of gained over my time as a software engineer. This talk is going to be a little more high level than some of the other ones we've heard, and there won't be quite as many code samples, because I'm more interested in giving you a framework for how to think about the strategy that your team uses, and less so about specific instructions to follow. So, as was noted, my name is Trent Willis, and like Jay, I work at Netflix. And relevant to this talk, I was previously the project lead for the QUnit testing framework for a number of years. And I learned a lot while maintaining that project, as well as through visiting a bunch of conferences and talking with developers all over the world. And testing is an aspect of development that, unlike a lot of engineers, I actually really enjoy and is really close to my heart and something that I enjoy thinking about and talking about. And what I've seen over the last 5 years or so is that even though we as an industry kind of regard testing as this best practice and something that we really should do, many developers I speak to don't really think it's actually that valuable. And even if they say they think it's valuable, when it comes to what they do in practice, oftentimes their actions speak differently. In other words, I think we all have this expectation that modern web apps are really well tested and everyone's writing all these tests. But what I've found in talking to folks is that a lot of applications are untested or at least under-tested. That is, you ask the developer if they're writing as many tests as they think they should, and they'll probably tell you no. Now, I haven't done any real formal research or studies as to why that's the case, but anecdotally what I've found is that a lot of developers say that testing just takes too much time, that it slows them down and they don't really feel like they're getting much benefit in return from it. And personally, I don't think that this perception is unfounded, but I think it is kind of exaggerated by a couple factors. The first is that I think many developers put kind of unnecessarily or maybe even unrealistically high expectations as to what testing a software application should look like. Right? They feel like they need a super comprehensive testing approach that takes lots of time to implement and can really impact your timelines to deliver things. And I think this is largely caused by a lot of our popular testing wisdom in the web space is that you need this multi-layered approach regardless of the nature of your project. You know, things like the testing pyramid or the testing trophy models where they say that you need to write end-to-end test and unit test and integration test and you need to do linting and you should have type checking. And when you're working on a new project or a small team, that's just a lot to ask. Additionally, I think that there is this abundance and maybe even an overabundance of testing options available to us today. And so this makes developers feel like we need to be using a lot of different tools in order to be really comprehensive in how we're testing our applications. So I think these things together have created kind of unnecessarily high expectations for us. The second reason I think testing feels really inefficient to a lot of us is that, truthfully, I think we just have not invested enough in our testing skills. A lot of developers, I don't think, really realize this, but the code patterns that you use for test code are substantially different from normal application code. The libraries you use, the patterns you employ, and potentially even the environment that the code runs in are likely different from your normal application code. And the reality is that writing good tests is actually a pretty different skill, in pretty much the same way that building web UIs is a different skill from writing backend services, even if you happen to use JavaScript for both of them. And so a lot of developers I've talked with think that just because they were able to implement the application means that they would know how to write good tests for it. And I think that is partially true. I think it is true that you will likely know how to write good test cases. You'll know what to test. But that doesn't necessarily mean that you'll know how to write the test code without investing in developing that skill. So learning good tests, it's a skill. Work on developing it. If you want some resources, come talk to me and I can point you in the right direction. And the final reason that I think a lot of folks find testing to feel a little inefficient is that many developers have only ever really seen unhelpful tests. Someone just before this talk was talking to me about how they had a bunch of tests that they thought were passing for a long time, but turns out the test runner wasn't working right, and then when they fixed it, a bunch of tests failed. And I think that's the reality for a lot of us. For example, imagine you have a test that looks kind of like this. It starts by getting a submit button by looking for the text submit in your page. And then you check to see if that submit button is enabled, or rather not disabled. But the tricky thing about this test is that if that submit text is wrapped in a span, you are going to be checking the wrong element, and this test will always pass, even if the button is disabled. And so if you spend a lot of time writing tests like this, or other similar faulty patterns, then it's going to be not really providing you with any value, because your application may be broken, but your test will say it's still good. So I think when we put all these things together, the perspective that like testing slows you down and isn't that helpful is kind of a valid point. At worst, I've seen teams adopt generic popular testing strategies and wind up being worse off because of it. Because they introduced so much overhead without providing the team with any real value. That said, I wouldn't be giving a talk about testing or testing strategy if I didn't find value in it still. And so I want to encourage you to kind of, I guess, toss out some of your preconceived notions about what testing should look like or how you get value out of testing, and instead focus on finding ways to test your application that provide you with quality results and not necessarily the quantity of tests. So how do you create a strategy that does that? Well, first, as with most things, you need to start by defining your goals. And when I ask developers what they think the purpose of testing is, I usually get a range of answers. But I think for most of us, when we really get down to the core of it, it's really just about ensuring that our software meets its requirements. That is, that our software does what it is supposed to do. But most modern software, especially web applications, are constantly changing, right, and being iterated on, usually pretty rapidly. And so we have to verify those requirements over and over and over again. And that's why we try to automate things, so that way the overhead of that is much less. But I think an important thing for us to acknowledge is that in an ideal magical world, where we could write our software code once, and then everything is perfect, and there are no bugs, and everything is implemented, we wouldn't really have bugs and issues. That the best way to not break a piece of software that you've created is to not change it. But the reality is that we have to change software. At the very least, we usually are adding new features or fixing bugs that we did introduce. But sometimes it's just because another team or another open source library decided to change, and we need to update our application to continue being compatible with it. And so ultimately, what all this means, and why I'm kind of getting a little philosophical here, is that when we talk about our testing strategy, we're really making a trade-off between our iteration speed, how quickly we can make these changes and improvements to our application, and the confidence that we have that these changes aren't breaking our application in some way. Or, put a little more positively, confidence that all of the requirements for our application are still met. These two things have sort of an inverse relationship of sorts, meaning that the higher your level of confidence, typically the slower your iteration speed. And I think a lot of developers are familiar with this relationship through the infamous Facebook saying of move fast and break things, right? You move quickly and you have low confidence that you're not breaking something. On the flip side, though, I've seen a lot of developers in the last few years talk about this idea of no deploy Fridays, which is basically saying, hey, we're going to move really slow, but we're going to have really high confidence that we're not breaking something over the weekend. And so this is one way that I like to think about the relationship between our investment in testing. You can invert it a little bit, though, and talk about how your time spent on testing will increase the level of confidence that you have. And I personally prefer this framing a little bit more, but it's a little less intuitive to visualize the quotes that I put on the last slide. Because the goal of testing, in my mind, is to optimize the amount of confidence that you're getting for the amount of time that you invest in your testing strategy. Or put a bit more simply, you can ask yourself, what is the least amount of time I can spend on testing and still be confident that my application is working the way I want it to? And to figure that out, you kind of have to ask yourself, how much confidence do I actually want? Now, quantifying confidence is not really possible because it's a very qualitative thing. But there are some questions we can ask ourselves to help guide our thought process and kind of give us a rough estimate of what we might be looking for. Those are, what stage of development is the product at? What are your users' expectations of your product? And then what are the market's expectations of your products? To unpack that a bit, what stage of development are you at? Are you working on a prototype like my team was? Or are you beta testing with real users? Or is your product an established product that makes your company money and that a lot of users rely on every day? Hopefully it's somewhat obvious that as a product matures, you need more confidence, right? Similarly, newer, more experimental projects should be more concerned with rapid iteration and getting new features out so that way you can grow your user base. Another way of thinking about this is that the stage of development that you're at also impacts how confident you are that your requirements are stable. And your confidence level should probably mirror that confidence in the stability of your requirements. For example, a prototype that you're working on might make big sweeping changes frequently as your user research finds out what it is that users actually want from your product. And tests you write during that phase may need to be rewritten in a week or 2 weeks before they have actually had any chance to provide your team with the value for the time that they invested in writing in them. So consider the stage of development that your project is at. And then second, you can ask yourself, what are my users' expectations of my product, specifically around things like availability and reliability? Now, I think most users of pretty much any product or website out there would say, I want it to work when I want to use it. And I think that's reasonable. But I think the severity of the reaction that they would have to your service being unavailable is going to depend on a number of factors. For instance, is this a product that you're working on that people need in order to do their job? You know, something like Slack. Or is this purely for entertainment, like a mobile app game? Is this a product that users are paying to access? And if so, how much are they paying you? And is this product used 24/7, or is it really only used during certain windows during the day? The cost to access and kind of the criticality of your tool or your product are going to be directly related to the level of confidence that you need when you're deploying changes to it. Outages for critical tools that customers pay a lot of money to access are going to have much stronger negative reactions from your users when there are problems. For example, if you work in finance on a high-volume trading application, you probably need to be extremely confident that when you deploy a change, especially during hours that the stock market is open, that you're not breaking something, because you can cost people tons of money. On the flip side, if I'm working on a mobile game that's just for fun and isn't monetized in any way, then I feel like it's probably not as big of a deal if there's a problem. So consider the expectations that your specific users are going to have on your software. And then finally, you can ask yourself, what are the market's expectations? These are expectations of your product by virtue of what market you are operating in. For example, a startup in the AI space is probably expected to deliver new features and have a lot new fancy demos all the time right now because it is a very hot market. And on the flip side, an advertising tool that's primarily geared towards kind of older businesses is probably a lot more interested in stability and making sure that users are getting their ad dollars and not necessarily being interrupted or having fancy new features. So in a way, this is similar to user expectations, but is more specific towards your market that your product is in and not your product in particular. And it's important to understand this because having an understanding of your product market allows you to avoid over or under investing in your testing strategy. Because the reality is, if you work in a space where everyone else's products are super stable and don't experience major outages, and your app has outages pretty regularly, then it's going to be a competitive disadvantage for you. On the flip side, though, if all your competitors are constantly breaking and having issues, and you put even a little bit of effort into making sure that your app is stable, then it will be a competitive advantage for you. So if we go back to the story from the start of the talk and my team's kind of new experimental app we were working on, the way we evaluated this looked something like this. We were at an early development stage. We were making lots of changes, doing lots of user testing, and iterating on the product in response to that. Our user expectations were pretty low because we didn't have that many users, and the ones that we did had alternative tools that they could fall back to when they needed. And the market space that we were in is a pretty new market space, but we were kind of playing catch-up with some of the external tools that were out there. And so we were much more interested in iterating quickly to catch up with them. And so all these things together suggested that what we really wanted was a lot more iteration speed and not necessarily a ton of confidence in our changes. So once you have a general understanding of your project's needs in regards to those things, then you can start thinking about what options you actually have to build the confidence and iteration speed that you need. To start, there are a lot of ways to build your confidence in your changes that go beyond what many of us think of as quote-unquote testing. And a lot of these, I think, actually feel a lot less disruptive to our workflows, and a lot of them, I think a lot of folks have already adopted. For starters, there are things like static analysis tools, which we've already heard about several times today. Linting has been a standard practice for many years, and many people are doing it. Some would argue we need to do it more. And then also type checking, whether it's using TypeScript, as most of you seem to be doing already, or using something like Flow, or even just old-fashioned JS doc comments that you then validate, type checking can provide an extra layer of security for you. So these don't necessarily validate that your requirements were met, but they do help prevent a lot of errors that would be bugs, which are not part of your requirements, and they do so without introducing an additional step to your workflow. Initially, they might add a little bit of friction, but once you've worked with them a while, they kind of just become this natural part of your workflow, and it doesn't really feel like something extra that you're having to add on to it. In a similar vein, you can also make ideological changes or changes to the way that you approach writing software without introducing entirely new tools or processes. For instance, you can focus on reducing the size and complexity of your components and modules. Smaller, less complex components and modules are easier to change without accidentally breaking something. Similarly, you can strongly encapsulated modules, or modules that quote-unquote hide their internals well, are a lot easier to change without issues as well. You can also look into things like solid design principles, especially the S in that, single responsibility, or patterns like presentational and container components, which is a bit dated, but still useful in a lot of applications. And so these ideas help you write code that is less likely to break in unexpected ways when you eventually have to change it. And this is kind of similar to the defensive coding practices that anticipate how your code might evolve, like Jay talked about earlier. And finally, you can also look into processes that build your confidence. Most teams nowadays do code reviews. Some still don't, especially smaller ones. But they're a great way to build extra confidence in the code that you ship, as well as build redundancy of knowledge within your team. Plus, many of the changes I mentioned on the ideological changes slide will make this process easier and therefore even more beneficial to your team. You'll also want to make sure that you're doing things like having easy and fast deployment, so that way when there is a problem, you can quickly roll back or revert a change, or deploy a hotfix if you know what the problem is quickly. You can also use more advanced deployment techniques, things like canaries and A/B tests that allow you to basically deploy and test your application changes to a small subset of your users before rolling it out to all of your users. And then finally, Looking into things like observability and monitoring, which are popular for backend services but aren't as common on front-end services. Things like Sentry or Datadog or Grafana can help you detect and alert you of issues before your users potentially even notice them. So there's a ton of options here that are available to you that allow you to raise your level of confidence in your changes without ever even writing a test for your application. So in the project I mentioned earlier, we have been using most of these approaches to help us build our confidence and deliver features quickly without necessarily writing explicit test code. And this has been especially helpful as we've been in these early stages where our requirements are rapidly changing. Okay, what about actual tests though? This is a testing talk ostensibly, and we are 20 minutes into it. Unit tests, end-to-end tests, integration, smoke, acceptance, regression, functional, behavioral. And there are probably some other different types of tests out there that I'm forgetting. The number of different terms we have nowadays and kind of the nuances and idiosyncrasies that people associate with them, I think makes having conversations about testing a little difficult. And so typically, I find it really only useful to talk about two types of tests, at least for the front end. And those are, first off, tests that validate a user flow from end to end, and tests that validate an isolated unit of functionality, or rather, tests that don't test an entire user flow from end to end. And this is roughly equivalent to how I would define end-to-end tests and unit tests, but you could debate me on the nuances. But I think it's important to focus on these two categories because it's relatively easy to define them, and more importantly, there's not much overlap. So it's pretty easy to tell what is a unit test versus an end-to-end test. Many testing strategies, like the pyramid and trophy that I mentioned earlier, also like to include integration tests as a category. Except for in practice, pretty much every team that I've worked on has a really hard time delineating when a unit test becomes an integration test, or when an integration test becomes an end-to-end test. And so that fuzziness makes it really hard to talk about your testing strategy because you get stuck in this debate of the nuances of what is a unit test versus an integration test. And so just dealing with two categories, it becomes a bit easier. So end-to-end tests are any tests that validate an entire user flow from end to end. These can be as simple as going to a page and then clicking a link to validate that it then bounces the user out of your application. Or it could be as complicated as testing that when a user visits your web app for the first time, they can go through a sign-up flow and then complete an onboarding flow as well. They involve testing your application as closely as possible to what a user would do. Common tools for this nowadays are things like Cypress or Puppeteer or Playwright. And typically, these tests are fairly complicated to write because you have to have the application working as it would in production. And they're usually a lot more likely to be slow and flaky. But they also provide us with the highest level of confidence that a user flow actually works from end to end. Unit tests, on the other hand, are any tests, in my opinion, that validate an isolated unit of functionality without necessarily mimicking how a user would use your application. You know, things like the test I showed earlier where validated that a button was disabled or enabled under certain circumstances, or maybe a specific complex data transformation that needs to happen on the client. They don't necessarily use the application the way a user would, and they don't represent complete tasks, but they contain logic that you feel is worth testing and validating. Unit tests are generally simpler to implement, faster to execute, and a lot more stable, but they don't give you any guarantee that a user could actually accomplish a given task in your application. So at the end of the day, which of these two types of tests is more beneficial to you and your team is going to depend a lot on, one, the nature of the project you're working on, but then two, also just what your team is more comfortable with. I think in an ideal world, myself and a lot of other developers would argue that end-to-end tests are actually more valuable. However, in reality, almost every project I've worked on has gotten a lot more value from unit tests. And there are several reasons for this. End-to-end tests, like I mentioned, often are slower and more flaky, and most web apps nowadays are complicated enough that they would need lots of them to validate even just their core user journeys. And so those two things together can make them a big drag on your development velocity, especially when your test suite fails for unknown reasons. As well as end-to-end tests can still be pretty time-consuming to write, even with modern tools like Cypress. It's gotten much better than it used to be, but it's still not perfect in my opinion. So all these together, I think, lead to end-to-end tests just being a drain on a team's time, which leads to them being underinvested in. Unit tests, on the other hand, don't typically suffer from that same issue. And the reality is that doing one or the other well is better than doing both poorly. So most teams I've worked with, when push comes to shove, eventually kind of give up on end-to-end tests and rely instead a lot more heavily on unit tests and other practices. At the end of the day, valuable tests are going to be those that catch issues for you. Whether unit or end-to-end tests or something else, writing, running, and maintaining your tests costs you time. And until a test actually catches an issue, it hasn't really provided you with much value. So to kind of sum up these different categories of confidence builders that I've talked about, non-testing techniques can give you a reasonable amount of confidence for, in my opinion, relatively low time investment. Unit tests can give you a bit more confidence, but usually require a bit more time investment as well. And then end-to-end tests give you the most confidence, but require the most time investment in my experience. And none of these, it's important to note, will ever get you to 100% confidence, right? The nature of software is that it's just so complex nowadays. It's impossible to be 100% certain that all of your edge cases are covered, all of your bugs are squashed, and you're not, missing some sneaky async bug. So with all those options in mind, you can start to put everything together, right? You can take kind of the goals and the objectives for your team and combine them with all these different options that I just talked about and form a strategy that makes sense for your project. Now, I can't cover every possible scenario, but I broadly like to think of two different buckets of situations. Those where you want more iteration speed than confidence, and those where you want more confidence than iteration speed. So to start, if iteration speed or going fast is your primary concern, then the question really becomes, what can you do within the time constraints that your team has? That is, what testing techniques can you add into your existing timelines? So as an example, maybe you have barely enough time to deliver your project as it is. I've seen a lot of teams get into this state, especially when they're in crunch time to deliver the first or second iteration of a project. So maybe you decide to just do linting and type checking, which you're probably already doing anyways. And then you make plans to later add in some end-to-end tests and make sure that you can quickly deploy in case there are problems. And you decide that actually gives you the level of confidence that you need during that phase of development. On the flip side, maybe you're in between that first alpha release and your second beta release with users. And so you decide that during this gap, you have a little bit of extra time and you want to focus on some ideological changes. You refactor the monolithic modules that kind of built up early on in development. And then you add in some unit tests for complex data logic that you know is not going to change in the future. On the flip side, if you have confidence as your primary concern and not necessarily going quickly, then the question becomes, what options give you the level of confidence that you want? As an example here, maybe you have a read-only app, and so you decide that all you really need for this is some end-to-end tests that take visual regression snapshots, and then you continue doing the linting and type checking that you're already doing. And maybe that's enough, right? That's it. You don't need unit tests because there's no real need for it. On the flip side, or the opposite end of the spectrum here, maybe you work on a dashboarding application, like myself, that is super complicated and has virtually an unlimited number of configuration options and as many interaction patterns to match. And so you're going to focus primarily on adding lots and lots of unit tests to cover all of those options. And then you'll have some end-to-end tests to mainly validate the different combinations of options at some level. And then you focus on making sure that all your modules are small and easy to refactor. And then you add in fast deployments and the ability, and code reviews are mandatory, so that way you can make sure someone else is giving an outsider's perspective. And then finally, you also do linting and type checking. And so this strategy is obviously very different from the one on the last slide, but both make sense for the type of project that you're on. As Anna said yesterday, maybe it's worth it. Sometimes maybe it's worth it to have the big image downloading, or in this case, the heavy, important, process-driven testing strategy. And then sometimes it's not, and that's okay. In short, your testing strategy should balance your time investment with the level of confidence that you need out of your project. It's important to note that this is at a given period in time, right? And the examples I mentioned where iteration speed was more important, they were tied a lot more to where the project was at in its development lifecycle. As the project moves along, the needs of testing might change. You should plan to revisit your testing strategy periodically. Picking one approach up front and kind of just sticking with it forever and for all of your projects is rarely ever optimal. And at worst, in the long run, it makes us really resistant to change and to new ideas. So I mentioned earlier, the project my team was working on was primarily using those non-testing options that I talked about. However, we also identified that before we ever do a generally available launch of our product, that is, telling our users that it is stable and ready for them to use for all of their needs, we acknowledged that we would add in end-to-end tests for the core user flows that we had, because we wanted to make sure that those things continued to work from that point forward, because at that point, our requirements would have stabilized. So that kind of brings us to the end of the talk here. In case I went a little long or you just weren't paying attention, the way you develop a testing strategy for your team is pretty simple at a high level. You define your goals, you evaluate your options, and then you make choices. I think the reality is that this seems pretty simple and maybe even a little dumb when I lay it out like this, but experience has shown me that most developers don't even spend this amount of time thinking about their testing strategy. They just kind of take what they've been doing and slap it into the new project, and off they go. And so it's really easy to do that. But taking the relatively small amount of time to develop a custom testing strategy is a win for everyone. As Martin kind of reminded us yesterday, our software should serve our users. And a custom testing strategy benefits our users by making sure that we can either deliver features and improvements to them faster, or can make our product more stable so they experience fewer interruptions. Or in the best case scenario, both of those things. And that in turn is going to benefit your company and your business. And that will be a benefit to your team as well, because it will make you all look good, and it allows you to avoid overly burdensome processes that you're not getting much value out of, or on the other end of the spectrum, allows you to avoid feeling guilty because you feel like you should be doing more testing, but you're not. So I recognize this talk was a lot more high level and abstract than many we've heard this week. But the goal was to give you a framework for how to think about this sort of strategy in your software development. So I hope you walk away with at least one new idea to kind of discuss with your team or maybe bring back to a project that you're working on. And as a closing thought, I want to say you don't need to reinvent the wheel. Like, you don't need to come up with something super wild and new or develop a new testing tool. But you also don't need to use the same wheels that everyone else is using. This is true of your testing strategy, but also of many other things in software development. Okay, that's all for me. If you have any questions, please come find me after this. I'd love to chat with you about your particular situation or any other questions that you might have. If you want these slides, you can find them on Noticed at that URL. That's all. Thank you.